Hello dear viewers, good day to you all. You're welcome to today's class. I remain your pro guide, Aisha Bande. Today's class is sponsored by Proch Connect. Kindly go to Play Store and search for Proch Connect and get started. Okay, so we have a question to solve today, which is from Federal University, Local JAR from Kogi State. This is Math 203, a past question from 2021-2022 academic session. So the question reads, so we are going to solve question 6a, which reads that show that the series 1 plus 2 square over 2 factorial plus 3 square over 3 factorial plus 4 square over 4 factorial plus dot 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 is convergent. However, from this question given, a hint for us to solve this question by using what we call the ratio test. But before we begin solving this question, I would love to explain what we mean by the ratio test and also some of the real-life applications of the ratio test. The ratio test is a method that is used in mathematical analysis to determine convergence or divergence of an infinite series. So that's simply what we mean, what the ratio test is all about, what it entails. Mathematically, the ratio test is given as the limits as n tends to infinity, absolute value of an plus 1 over an equals to L. So this is the mathematical representation of the ratio test. However, there are three conditions under this ratio test. If after solving and we get the value of L to be less than 1, then we say that the series is convergent. Okay? But if we solve and the value for L is greater than 1, we say that the series is divergent. The third condition is, if L is equal to 1, we say that the series is inconclusive. Okay? So when L is less than 1, the ratio test is convergent. When L is greater than 1, the ratio test is divergent. And when L is equal to 1, the ratio test is inconclusive. There are three things the ratio test comprises of. We have the factorial, we have n raised to the power of n, third one, which is known as the exponent. So what this means is that ratio test comes either factorial or it comes in form of n raised to the power of n, or it comes in form of what? Of exponent. Okay, so looking at this question we have here now, this question is a factorial one. Okay, so another thing we need to know under the ratio test is the real life application. Ratio test in real life is used in engineering to check the stability of any algorithm. It is used in finance to check for risk assessment. It's used in physics to check for quantum mechanics and also reaction kinetics. Going to medicine, ratio test is used to check drug concentration model and also used in epidemiology. In statistics, ratio test is used to check for convergence or divergence of a series, and also it is used in testing of hypotheses in statistics. So these are some of the real life applications of the ratio test. So let's begin the calculation aspect. So since we have all of these conditions, so this is the formula we are going to use to find to check if this series is convergent or divergent. So let's begin. From here, looking at the formula, we're going to get for a subscript n plus 1 and a subscript n. Okay, so now we can begin with a subscript n. This is equal to, looking at the series that has been given, this shows that it is n raised to power 2 over n factorial. So this is a subscript n. Let's get an plus 1. Okay, so this is going to be n plus 1 or raised to the power of 2 all over n plus 1 factorial. So now we have the two values needed here. Now we substitute in the values and we simplify further. So an plus 1 now is going to be represented as, so now we're going to take the absolute value of n plus 1 square all over n plus 1 factorial, all divided by, now the value for a subscript n now is n square over n factorial. So this is the absolute value. From this point now, let's simplify this. So this is the same as saying n plus 1 whole square divided by n plus 1 factorial. So this line we have here is a division line. So this is divided by n square over n factorial. Okay, so simplifying further, here we have n plus 1 over n plus 1 factorial. This division turns to multiplication, which is n square over n factorial. Simplifying further, we have n plus 1 square. So n plus 1 factorial is going to give n plus 1 multiplied by n factorial times n factorial over n square. So let's see what we can cancel out from here. N factorial cancels n factorial. We can see that one of this n plus 1 square cancels one of it here. So we are left with n plus 1 over n square. So let's simplify. So simplifying this becomes n over n square plus 1 over n square. So what this n cancels one of this n, left with 1 over n plus 1 over n squared. So from here now we can now take the limit as n tends to infinity. This becomes, so when we take the limit as n tends to infinity, 1 over n becomes 0 plus 1 over n, so n squared also becomes 0. 0 plus 0 is equals to 0. So we have our final answer to be equals to 0, and this shows that L is less than 1. So since n is less than 1, it means that what, as I've explained earlier, when we have n to be less than 1, it means that the series is convergent. Okay, so that means, so 1 plus 2 square over 2 factorial plus 3 square over 3 factorial plus 4 square over 4 factorial plus that shows that is a convergent series. So this is all we have today. If you have any question, kindly bring in your questions that are different from what we have solved today. Thank you for watching. I remain your pro guide, Aisha Bandi. Bye for now.